I'd like to introduce you to a new product that Ansys has brought to the forefront called SynMatrix Filter AI Plus. SynMatrix Filter AI Plus is a software suite that operates outside of the electronics desktop. It comes from our software partners at SynMatrix. You can see them at synmatrix.com. But this is a tool that is an all-in-one software platform for filter design and manufacturing, and they interact and connect directly to HFSS to furnish very accurate physics-based simulation data for both the full filters and also for resonator designs, individual resonator designs that are used in the process of designing the filter. Now, they will handle a broad class of filter topologies. They will reach down and use HFSS for computer-aided tuning and AI optimization. And then, of course, downstream, they can interact with test and measurement equipment when you have to tune filters by hand based on response that you're seeing. This tool starts with filter synthesis and specification analysis. You bring a set of specifications for your filter along with a topology that you want to be able to realize it in, and it will synthesize the filter design, the golden matrix for all of the couplings for a particular order of resonators designs. You can incorporate your own zeros into the functions and move on to actually creating or synthesizing the physical design of the filter. It will generate 3D geometries automatically for cavity, waveguide, microstrip filters, and substrate integrated waveguide filters. You can do frequency and Q analysis and mode chart analysis for individual resonator designs, and then it will also synthesize resonators to come together to form a full multi-order filter. You can tune these filters automatically using their AI optimization or do it by hand. The software has very good facilities for both, and it maintains constant connection to a fully synthesized structure in HFSS of your complete filter so that you can evaluate it quickly and easily and very accurately. They can also connect, as I said, to test and measurement equipment. So for real-time production tuning, they have support for this as well. We'll offer comprehensive filter synthesis for bandpass, low-pass filters, bandstop, and filters, and multi-band filters, also diplexer and triplexer systems. And you can realize these systems in advanced topologies. There's thousands of practical solutions that you can develop for your filter design to meet your specifications. It's fully integrated, as I mentioned, to Ansys HFSS, so you can perform, for example, Monte Carlo analysis and yields analysis for your models that would account for process tolerances, fillets, control in the fabrication technology and so forth, so that you could understand what variations you might expect when you're building 1,000 of these with a particular manufacturing process. In addition, since it does connect to HFSS, you can also perform coupled thermal analysis. You can leverage HFSS, the HFSS multi-paction analysis simulation, and then connect also to the broader Ansys tools for thermal and mechanical analysis to understand stretching and shrinking and the possible detuning of the structure if it warps a bit because of heating. And then finally, optimization, computer-aided computer-aided tuning and AI optimization with the 3D modeler wrapped around HFSS for space mapping. Now, we can also synthesize and design duplexers and multiplexer designs and optimize them. So that would be for T-junction types or common resonator types. So it has a very comprehensive capability for diplexers, triplexers, and multiplexers, and results in fully parameterized 3D geometry, again, with HFSS. You can see some planar filter design candidates here, open loop types, bandpass filter types, and creative resonators. If you have resonator types that you're exploring, which are not in the common canonical types, you can bring those also and create your Q curves and so forth for those. And we'll also realize Chebyshev, Butterworth, elliptic and elliptic type filter synthesis for planar distributed transmission lines. Another area that's becoming very popular in millimeter wave designs is substrate integrated waveguides, which are fabricated into single and multi-layer printed circuit board processes. And LTCC and so forth, and we can also design filters, some very creative filters into those topologies. That's becoming very popular for millimeter wave systems today. Now, I mentioned that this does couple to um, couples to the HFSS world, but the SynMatrix interface will give you a very nice smooth flow for developing and orienting your filters so that you can get things set exactly as you wish, including a rotation of your cavity resonators, for example, or repositioning of those resonators. So you can rotate the cavities as you want, set them in order to realize a certain topology that you need to have. And when it's time to come up with transmission zeros, you can incorporate, I think they probably support 8 different transmission zero realizations for how you physically fabricate those. Like in this case, a disc probe or a loop or a probe that goes through and position those and put them between the resonators of interest so that you can properly tune that filter to bring close edges in or introduce a multi-band capability. I'll also show you here, I'll run the second video at the same time that will show us a diplexer design that's being synthesized in HFSS. And you can see here, when you punch the button to create the filter design, it automatically builds it up. And you're just watching the sequence here that's automatically done by SynMatrix as it synthesizes the filter. You don't have to do this by hand. It builds it, and then as it builds it, it fully parameterizes every aspect that is tunable in that filter for you, which is necessary later when we perform computer-aided tuning and AI-based optimization of the filter design. So that gives you a sense for how integrated it is to the HFSS package, and it will maintain its connection to HFSS. So if you make a change to the design in SynMatrix to modify some dimension, it will automatically update the connected HFSS model. And then, of course, you can export this model into any one of the probably 15 or 20 three-dimensional structural file formats that we support. I know we're a little bit over time. I'll keep this short here as we finish up. But in computer-aided tuning, which is kind of the important part of filter design, because the first design doesn't usually work as well as we would like it to, we can perform advanced coupling matrix extraction and use two-port tuning techniques to bring things in, or advanced algorithms that will also incorporate dispersive effects and spurious prediction. So you'll see the parameter list if you use this tool. The parameter list is here that will correspond to the HFSS structure control, and any of these things can be changed. Here you can see when we run our first run through the computer-aided tuning example, we've got a stack of the parameters that are tunable here, and it shows us what appear to be the errors. It takes an assessment of the errors of any one of these parameters for comparing the filter's measured response against the ideal response, the developed design response. Now, you can also introduce internal ports. SynMatrix can do that if you want to do port tuning optimization, and that can sometimes significantly reduce your EM solves a bit with internal port tuning techniques. Now, you can tune these filters with that parameter list in the frequency domain, so we can check and see how we're doing in its tuning response. But it's also useful for filter design to look at the time domain response, because that gives us a sense for how each of these resonators is responding compared to the golden matrix prediction, so that we can better understand which resonator is off and which one should we tune. Now, the intelligent optimization simply reaches down to HFSS and has some intelligence related to how filters operate. Right? Not every optimization algorithm works well for filter tuning, because filters are incredibly sensitive, and there are algorithms that work well and algorithms that don't. And we've built the automation into the tooling to make it possible to do this perturbation analysis, where we do model variable adjustment using the AI algorithm. This relies on HFSS simulation to extract the coupling matrix information. We compare it to the golden matrix and then make adjustments and repeat the process until the solution has converged. So here's an example of an L-band filter where the response is not so good. It's close to the right frequency, but we don't have the broadband that we're looking for. So going through our automated process, we see that there are a couple of resonators that are some ways out, M22, 33, and 44. So we can push the get new dimension button, which will readjust the structure of the filter and resimulate. And now we're getting closer to the right response. So when we run through about three of these computer aided tuning runs, it takes about 4.5 minutes. All the dimensions are changed to reduce the coupling matrix error, and now we're getting the passband centered and the width is about right. And then we send it through the automated loop. We go through about 11 iterations. It takes about 20 minutes to finish, about an hour for 30 iterations complete, and the modeled response is very good compared to the ideal golden matrix design. All of this, again, you don't have to be a filter expert in order to do this optimization. It's does a good job of automating that. I want to point out that some significant filter designers in the world are using this software. MDA is one of the customers who use this software package with good results. They're very happy with it. Okay, so in conclusion, Ansys SynMatrix Filter AI Plus to synthesize filters, evaluate resonator Q and frequency, evaluate interresonator couplings, create geometries, optimize the filter performance, look at yields, power handling, thermal and environmental analysis, very important, and also recently added diplexers and multiplexer designs.